Hello there, ladies and gentlemen. Today we're going to talk a little bit more about logarithms and talk about some of the more basic properties that we can do with logs before we get into some of the more complicated ones. So here's a couple different equations. I want you guys to go ahead and pause the video for a moment and see if you can figure out what y would equal for each of these. So doing what you know about logs, what would y equal for all of these? Okay, so for each of these, hopefully what you realize is that in order for this to make sense, if I think about writing it as an exponential, okay, this would say 3 to the y equals 3, right? So the base to this should equal this. Well, that means that y would have to equal 1. And for all of these, yeah, y is equal 1 for all of them, okay? And knowing that fact actually is going to set us up for one of the properties that we can talk about, which these are the 4 properties right here. So if you guys want to please write these down, while you're writing these down, I'm going to go ahead and talk about each of them, okay? So the first property of logs that I want you guys to know is that if you have 1 plugged in into your logarithm, you're going to get 0. We actually talked about that one yesterday a little bit in terms of our logarithms, right? When we put in 1, we're always going to get out 0, okay? The next one is that if the base and the inside of your logarithm match, then it's going to equal 1. Okay? If the base and the inside match, it will equal 1. And that's actually what we saw on this part right here, right? The inside and the bases of all of these logs matched. So what are they going to equal? They're all going to equal 1. Okay, so that's another property of logarithms that we need to know. Another property is number 3, and this one actually kind of gets the label of the inverse property, because if you remember, we talked about how exponentials and logarithms are inverses of each other, and we can actually see that here. Log base a of a to the x should equal x, and a to the log base a of x will also equal x, okay, because they're inverses. When I compose them, put them into each other, I'm going to get x out. Okay, this is me putting a to the x inside a log base a, and I get x. This is me taking log base a of x and putting it into the exponential function a to the x, and I get out x as well. So the fact that they're inverses, that's telling me about this one right here. The last one is actually our one-to-one property that we talked about with exponentials as well. If we see that the bases of our logarithms are the same and they're equal to each other, then we know that the insides have to also be equal to each other, right? Kind of makes sense. If the log is equal to each other and they have the same base, those insides have to be the same, otherwise it wouldn't really work, okay? So here's a couple things that we can do using those properties, okay? We can go ahead and we can actually start to calculate the following if we remember these properties over here, okay? So, for example, I can see right here, log base 4 of 4 to the third, that's really kind of playing on this property right here, right? I have my base and I have an exponential inside it and they match. So what's that going to equal? That's going to actually equal 3. Okay, that's the exponent. That's kind of filling in for that x spot there. So now that's going to equal 3. Log base 5 of 1, well, 5 to what power gives me 1? That's going to equal 0. That's kind of playing off of this one. If we look over here, that's playing off of this top one right here, right? Anything with 1 inside is going to equal 0, okay? The log of 10, remember, if I don't see a base, it means really we're talking about base 10. Here, the inside and the base match, that's going to be equal to 1. That's following along with this property right here. If the base and your inside match, they equal 1. And then the last one, the log base e, right? Natural log is log base e of 1. Again, that's going to equal 0, same property that we talked about with this one up here. These properties also all work for the natural log, since the natural log is still a logarithm, just with base e, okay? Now for this problem, this is supposed to be in parentheses here, okay? But we have a log base 3 of 2x plus 3 equals the log base 3 of 3x. This is where our last property over here, the one-to-one, is going to come in. The insides of these logarithms need to be equal to each other, okay? They should be equal. And then I can go ahead and I can solve for x, right? Subtract 2x from both sides, subtract 2x, and I get that 3 equals x. Okay, so again, this one is using that one-to-one property. They have the same base. Their insides need to be the same. Last one, or another one we're going to look at here, okay, log base 5 of 5x equals 2. This one actually, instead of maybe thinking about it as a property, we actually can kind of think about a little bit what we talked about yesterday, rewriting this in that exponential form, right? So 5 to the second would need to equal 5x. So I can rewrite this as 5 to the second power equals 5x. Okay, and then I can solve it this way. So 5 squared is 25 equals 5x, and then divide by 5. And I get that 5 equals x. Now, this actually all comes from, and the reason why we talk about this exponential version, it comes from one of our properties that we have over here, okay? It actually comes from the last, or the second to last property, this one right here, which is the fact that they're inverses of each other, okay? Another way to think about this problem, right, so if I have the log base 5 of 5x equals 2, is actually what I could say is, hey, I want to do the same thing to both sides. What if I do 5 to each side? Okay, take each one and basically I'm kind of composing them by saying we're going to say 5 to the log base 5 of 5x and 5 to the second. What would happen there? Well, these are inverses of each other. They cancel each other out, and I would end up with just x on this side. And over here, or 5x on this side, right, the inside. Okay, and then over here, 5 to the second, that's going to give me 25. Okay, hey, isn't that what I ended up with over here when I was solving? 25 equals 5x, 5x equals 25. That's kind of where this comes from, is the fact that because they're inverses of each other, if I take 5 to each side, I end up with it equaling 5 squared or 25. Okay, so that is some of our properties we can talk about with logarithms, some of the extra things we can know about them. We're going to keep expanding on this and adding on more properties as we go. Thank you all for watching.